All right, so yesterday we worked on identifying functions, just whether or not something was a function. Today we got to be a little bit more specific. We got to identify a couple different types of functions like linear or nonlinear. So using Desmos, you got to make sure you got the green thing like you would have on a test. We don't want to practice these. Anybody think I could talk about linear? No, that they're crossing them. If I just had one of them up there at a time, the linear is there a straight line. Non-linear. Okay. Linear, a straight line, one way or the other. Okay. It could be horizontal, vertical, diagonal, anyway, but it's going to be straight. Okay. Everybody clear on that? Linear functions or linear graphs make straight lines. Okay. A lot of times, what we'll see is we will see things like linear function or is nonlinear. Okay. You write it exactly like it says. You put whatever's on top, put your slash, and then type what's on the bottom to get out from the denominator. Oh, the exponent? That too, sorry. So, ways we can do that. When you click the keyboard, the exponent do the B one. Is 4 of them in at once. Desmos So easy with Desmos, right? Bad news, a lot of this is on the inactive part. Variable has an exponent, it's going to be nonlinear. So if you see an exponent on either the x or the y, that makes it nonlinear. A variable is a denominator or on the bottom of a fraction. It could even be like x plus something on the bottom, but if it's on the bottom, it's going to be nonlinear. Y times y, those make nonlinear functions also. Okay? All right, y'all give this one a try. This time you're looking for which one is non-linear. I'm not going to type in all of them, but we got y equals 2 over x plus 3 minus 5. Later. Most, a little longer. All right. So what you do is you hit the plus sign on the top left corner of Desmos, and the second one on there says table. You click for a table. Y's are y's. So my x values are 2, 5, 8, and 11. For A, my y values are 1, 2, 4, and 8. When I zoom out, you should be able to see how the dots make a pattern. If you ever cannot tell by just looking at the dots, it's aren't all in line, right? So I go to answer choice B. I don't have to change the X values. All the X values are the same. So I'm just going to change my Y values. And you can see it's not right through the middle of those dots again, right? And if the line wasn't there, there is a bit of a curve to those lines. So I go on to C. I got -4, 1, 2, and 3. Well, that one looks even worse, right? So that means odds are good. That's D is going to be my answer, but we'll type those in. And you can see on the lines right here, the line's going right through the middle of all those points, right? That makes them linear. If we didn't have that line there, again, you should still be able to tell by looking at the dots. The problem is some of y'all get zoomed out from different problems. You got to make sure to zoom back in. Otherwise, all of them will always look like they're in a straight line. Any questions on that? Intervals. So an interval would be like a section or a segment. A lot of times we're talking about a little section, okay? An interval of it. And when it gives the intervals, it's going to give x values. So if it says from x equals 3 to x equals 6, what it's talking about is this part right here. Just that section with two words. First one is either linear or nonlinear. So is that one linear or nonlinear? Where it's highlighted. That's linear. We're only talking about the interval. We're not talking about the whole thing. So just in that section, that's linear. Decreasing. Two words here would be linear and Yeah, so if we're going from -3 to -1, we're talking about this little bit right here. Going up.